Hey folks, welcome back. In this video, we're going to go over the solution to challenge 6 together. This challenge was probably the hardest one yet, and that was because, as you saw inside the file, we were unopinionated about how you programmed this thing. The only thing that mattered was that your program met the set criteria. Now, after forking the repository and then cloning it, you needed to run a set of instructions in order to make use of the modules that were required for the test file. So really quickly, let me put the prompt side by side with my terminal here, and then I'm going to run these commands. We got pipenv installed and working together in the last couple of videos. Now, after cloning this repository, you're supposed to run pipenv install, and that will install the needed pexpect module for Python in a virtual environment. After that, I run pipenv shell to get inside the virtual environment, and then if I try to execute my test suite, you can see that we get a bunch of failures because we haven't implemented our program yet. Awesome, let's go ahead and solve this. Alright, if I scroll the prompt on the right side here back up to the requirements, you can see that your client has provided a list of preset users that should be in the system and allowed to enter the building. These usernames are supposed to be the keys in your dictionary, and then the values of these keys are going to be whether these people are checked in or checked out of the building. So before I implement any logic, I'm going to go ahead and go above the main check here, and I'm going to create a dictionary that is going to be my user directory. And these usernames are just going to be pasted in as keys. Now, for the value of these dictionary keys, you could have done pretty much anything, right? You might have decided that, hey, in and out can be just two values, so I could have just used true or false or booleans, right? However, the reason that I am going to use a string or in and out is because you can actually directly compare this value with the command that the user inputs, and it's easier. If you decide to use numbers or booleans, you're going to have to then convert to in and out, etc., and it just causes more work, basically. Okay, I finished writing my dictionary. That's going to be my user directory. Now, down here inside the main function or the main check, I'm just going to do a while true again. I'm going to create a variable here, user input, to take in the user's input. And now remember, the output of your program has to match exactly what's in the example, and so the prompt here should have just been input with a capital I, space. And now we get to the first tricky part of this challenge. Basically, whenever the user enters in a command, we have to check for two things. Number one, the very first item that they input is going to have to be their username, and then the second word in that line has to be either in or out. How can we process both of these things individually? Again, none of this is stuff that you've never seen before. So, if you don't remember, we learned about the split function, right? You could have taken the user's input and then split it, and that will create an array of each of the individual words in the command. And now we can do one of the checks. If this array is not exactly 2, that means a user tried to input a command that had only one word or had more than 2 words, and that right there is invalid. We can sound the alarm. And actually, since we're going to be sounding the alarm in multiple places, let's just create a variable with this message and then reuse that variable. That way we only have to type it once. Fantastic. And after that first check, this problem becomes a little bit simpler. We now have an input array with exactly 2 elements, and each of these elements can be checked against the remaining requirements. Just for clarity, I'm going to store these values in new variable names, that way we know exactly what we're working with. The first element is always supposed to be the username, and then the second element is always supposed to be the action, whether they're going in or out. And now we do our checks. Firstly, if the input username is not a part of our user's dictionary, then we sound the alarm. Next, if the user tries to do anything other than in or out, then it's also invalid and we sound the alarm, right? Remember your Boolean algebra here. If action is not equal to in and action is not equal to out. In other words, we're looking for the condition where their attempted action is anything other than in and out. And then finally, we have our last thing to check. Where the user's command is a valid command, valid username, valid action, but they're trying to go in again when they're already in, or they're trying to go out again when they're already out. This would be the easy check of just making sure that their action, the input action, is not the same as their current state. Now, notice here that if you wanted to, you could have done each of these sections right here, each of these conditions in their own if-elif line, but I didn't want to write print error message multiple times. And so instead of doing this, I'm just going to cut this condition right here and tack it to the very end of the very first if statement with an or. Now that right there should cover all of the error conditions. Once we get past all those checks, now we know that their action or the thing that they're requesting is valid, and then we just do it. The easy way to do this is just to set the value of the key equal to the action they're requesting. If they're requesting to go in, then you just set the value to in. And if they request to go out, then you set the thing to out. And I believe this fulfills our requirements. I'm going to go ahead and write my changes and execute my program. I'm going to do this manually first just to test it. M. Henderson in. Oh, I did not print the confirmation message saying what the user just tried to do. So let's go ahead and do that real quick. Okay, go ahead and open the program again. I'm going to go to the very bottom here and add a print statement. Print, space, indent inward, remember. Username, oh, I forgot the F for format. And then username is checked, action. Okay, good. Let's go ahead and write our changes and then test this again. M. Henderson in, M. Henderson is checked in. Okay, good. ZZ Dog in, ZZ Dog's checked in. M. Henderson out, M. Henderson is checked out. Elon Musk in, alarm set. Oh, wait a minute. We sounded the alarm and then we still checked him in anyway. Let's go ahead and take a look at that real quick, okay? I'm going to go ahead and expand to full screen and then open another terminal side by side so that we can look at our program and then look at the output. So we know that Elon Musk is not a valid user in our system, and so, that's what happened. So if you take a look at this if statement here, it failed this and it printed the error, but then this stuff is outside of the if statement, and so it went ahead and executed this anyway and checked him in. We don't want that. If this happens, we don't want to execute anything else. And so what I can do is I can add an else statement here and indent these two lines inward. This guarantees that both of these blocks of code will execute mutually exclusively. Okay, gonna do that, write my changes, execute and test again. Elon Musk in, alarm sounded. Okay, good, that's what we expected. Let's go ahead and pull the prompts back up and then check the rest of these. Enter rock out, alarm sounded, good. ZZ Dog in again, yep. And now, hubba bubba, blah blah blah. Oh, why did the alarm sound twice? What? Let's open up our program again. So if you take a look at this top one right here, it failed the very first check we did, right? Because it was more than 2 words. However, you can see here that we did the same thing again. We printed out the error message, but then the rest of this code still executed. And so there are a couple different ways we can address this. Number one, we can do the same thing that we just did a second ago. I can add an else statement here and then indent everything else inward to guarantee mutual exclusive execution between these two bodies. Or there's an easier way to do this. I'm going to use the continue keyword. The continue keyword tells our while loop to go ahead and skip this iteration of the loop and just restart. This basically guarantees that the rest of this code will not execute before the loop starts over. Alrighty, write the changes, execute the code again, blah blah blah, and there we go, only one alarm sounded. And that, I believe, fulfills our requirements. So let's go ahead and boot out of here and execute the test instead. And yeah, 6 tests, okay. Awesome, looks like we've fulfilled our requirements here. I'm gonna do a git diff to see all the lines of code that I changed. Very good. If I exit out of here with Q, git status, I can see that security system.py has changed. I'm gonna git add security system, git commit, fill in the message, and then git push. Alright, fantastic. Again, this challenge was a little trickier, but none of the stuff that was required to solve this problem is stuff that you've never seen before. It's all about piecing together what you know and what you've learned to solve problems. That's what software engineering is. That's also why it's so hard. You learn a lot of stuff, a lot of different ways to solve problems, and so this is where repetition comes in. You get better and better at it, you get more efficient, more comfortable with it, the more you do it. And that's why I'm having you do these challenges. That's why I have you go through the same commands over and over. It's to drill it into you.